Today's episode of Data Driven is brought to you by Audible. Get a free audiobook download and 30-day free trial at audibletrial.com/datadriven.
Hello and welcome to Data Driven, the podcast where we explore the emerging field of data science. We bring the best minds in data, software engineering, machine learning and artificial intelligence. Now here are your hosts, Frank Lavinia and Andy Leonard.
Hello and welcome back to Data Driven, the podcast where we explore the emerging fields of data science, machine learning, and artificial intelligence. If data is the new oil, you can consider us Car Talk because we focus on where the rubber meets the road. And in this case, the road is the information superhighway. With me, as always, is Andy Leonard. How you doing, Andy?
I'm doing well, Frank. How are you?
I'm doing fantastic. So I hear you've been quite the world traveler.
Well, I have. I was very fortunate to go to SQL Saturday Dublin a couple weekends ago, and then I spent a week in London delivering some training and visiting with some really cool people up at Redgate. And it was a great trip. I had an awesome time. I hear while I was gone, you were doing some more public speaking at another conference.
I was. Actually, it was this past weekend. So we're recording this on June 26th. And they had the first ever Data Intelligence Summit in Tysons Corner, Virginia, which is just outside D.C. It was hosted by Capital One. Capital One is a bank here in the States. And they have a massive, for a bank, a pretty big convention center kind of built into their headquarters.
Nice.
Which it was really great of them to kind of share that space. It was actually a 3-day event. Friday, Saturday, and Sunday. They had some cool swag. I had my son with me 2 of the 3 days. He was all about the fidget spinner.
Nice.
He was loving it. And it says data on it, which is really cool.
So well, that is cool.
He and I are going to have to share that one.
I saw your Facebook Live on Frank's World TV where you were sharing that. That was pretty awesome. What did you speak on?
I spoke on machine learning melee, Azure machine learning versus Amazon Web Services machine learning offerings.
That sounds very interesting.
It was very interesting. The whole talk has like a boxing theme. I even rang the bell. When I gave the talk before in St. Louis, I did the whole let's get ready to rumble thing, but I decided not to do it this time.
Did you have the mic suspended from the ceiling and everything?
No, and you know what? Next time I give the talk, I'm going to wear a referee shirt to really sell the thing. But it was a great conference because it was run by the folks who run the Pi Data conferences around the world. They did a great job because it was an interesting mix of academic types and actual practical engineering types. These two worlds are colliding, whether they want to or not. There's an assumption that there's some kind of hostility there or something like that, but I didn't find that. People, there was one gentleman who was a very big academic, and he loved the fact that, what did he call us? Implementers, right? He goes, it's not just academic, but it's also implementers at the conference. And it was a great mix and a lot of great sessions. If you subscribe to the Data Driven feed, we started doing something basically in Dublin where we we do live coverage using Facebook Live, and then we convert those to podcast episodes.
Right.
We've had, if we're just using kind of download numbers as feedback, it's been extremely popular. So if you have any thoughts one way or the other, if you're listening, let us know in the comments on datadriven.tv if that's a good thing. Certainly, we love doing it. It's great to, Andy got a hold of some really great people at SQL Saturday Dublin. We actually posted this morning your chat with Neil at a taco shop. Must have had open windows or something like that. You get the whole street ambiance of London in there, which was quite the challenge to clean up that audio to make it an enjoyable listening experience for our listeners.
You did a fantastic job on that, Frank. And we were sitting as a small shop. We were sitting near an open door. And, I don't know if people driving by saw me in there recording a video and honked their horn because of that or not. I'm just not sure. But, they're internet famous, or at least their horn is.
Right.
Because of our podcast. Lots and lots of fun. And speaking of lots and lots of fun, I got to meet our guest today, Darren Lacey, at a past summit. Darren Lacey is the architect for the BI and data science platform used to optimize Microsoft's global supply chain. His group makes awesome stuff like the HoloLens, Surface, and Xbox. A longtime BI expert and now aspiring data science practitioner, Darren loves nearly everything about technology and data and is exploring opportunities to relocate to a planet with a 36-hour day so there's more time for learning and writing our code. Darren is also a classically trained concert pianist and musicologist. As a graduate student, his passion for data was already evident as he crafted the university's first master's thesis in a field now called computational musicology. Darren continues to be inspired by folks like Mark Rusinovich, Uli Holman, James Whitaker, Hadley Wickham, Ralph Kimball, and finally his amazing wife Rebecca and their 2 daughters. Please follow Darren on LinkedIn. Thank you for being on our podcast, Darren, and welcome.
Thank you, Andy. I'm really excited to be here. I feel like I'm getting the better end of this deal, man. You guys are awesome.
Oh, thank you. Thank you very much. As we were talking kind of in our virtual green room before we hit record, you're actually probably the first guest we've had to have been interviewed after we launched. So we really appreciate that you've heard us and you still want to talk to us.
Andy and I do talk a lot, both professionally and just because we're both Southerners and like to talk. And that actually, going back to Andy's comment about meeting at PASS, I did have the good fortune of being in his session 2 years ago. I jokingly call it, probably like many people who have heard it, the I do what I want session. And, you know, Andy and his, in only a way that Andy could do, he describes how you can get in and hack the SSIS catalog, and he does it because he does what he wants. That's just the way Andy rolls. And I knew that Andy was a guy I wanted to talk to. So, yeah, we hooked up after the conference, and I said, hey, we were working on some SQL Server Stack BI stuff and supply chain at Microsoft at the time. I was like, Andy, you got to come help us out, man.
So how are things at the mothership these days?
Well, you know, there's never a dull moment, as I'm sure you remember.
Yes, never a dull moment.
This is the end of our fiscal year, so we're trying to get things wrapped up. We're transitioning into what we're going to be doing next year. So it's an exciting time. It's especially as a data professional at Microsoft. It's literally like living in the candy stores.
I am continually amazed and impressed at the stuff that Microsoft is doing in the data science space. I mean, it just keeps getting better. As a former Microsoft employee, it makes me extremely proud that, you know, Microsoft is definitely on the cutting edge of this. I mean, you see kind of the work and cooperation that they're doing with academia, as well as the influx probably of data science folks on LinkedIn. We were talking beforehand about the Machine Learning and Data Science Summit, I think. And I went to the one last year, and that was when I had my, I have seen the light moment. Time will tell if it'll be a pivotal point in time of my life, but it's definitely was an inflection point in my career.
Yeah, I've had the privilege of attending that. I think 4 out of the 4 years I've been at Microsoft so far, and it never fails to teach me something. So yeah, and this year was particularly fun with LinkedIn there. We had some good sessions from all around the company, so it was a really good year.
One of the things that I saw out of Build was the integration of artificial intelligence in places that you wouldn't necessarily think. The PowerPoint demo from Build was really mind-blowing.
Well, I'll have to check that one out. You have to send me the link. I don't think I've seen that one.
Basically, it'll do a real-time translation of a presentation.
Oh, wow. Okay. Yep.
They've already figured out kind of the hard bits of that for Skype Translate, but now they're integrating with other products.
That is a really interesting point. As I'm transitioning from being more of a traditional BI professional into a data science practitioner, I'm constantly amazed at how things are using machine learning that I didn't know were using machine learning. Or like you say, maybe it was originally built for one purpose and then it becomes a feature in a very traditional project and it's just kind of behind the scenes, making it even more magical than it was before. That happens all the time.
Yeah, we had Dr. Rima Nema on, I guess it's been a couple of weeks ago when the show went live. We recorded it right after Build. She was talking some about Cosmos DB and some of the feature engineering that's gone into that. I know that you enjoy feature engineering as well in machine learning, Darren. Why don't you speak to that?
If you do some research into how data scientists spend their time, even though people consistently call it the sexiest profession in the world, about 80% of the job is decidedly unsexy. And, whether it's data wrangling, feature engineering, or anything else you have to do to make the data more usable for machine learning applications, it's a lot of work. And feature engineering is probably where you get the most bang for your buck. There's a quote I could read by, I'm sure you guys know who Andrew Ng is. He says, coming up with features is difficult, time-consuming, and requires expert knowledge. Applied machine learning is basically feature engineering. And, for me, that really resonates because, again, coming from a traditional BI background for the better part of a decade plus, I'm used to doing only descriptive type of things, where I'm using the data I'm given. Maybe I do take some calculations and build them into my fact tables so that everybody's not calculating them in a different way. And that's very useful. But when it comes to feature engineering, that's just the start, right? Because when you get the data in, those raw features that are in your data only going to take you so far. Then you're going to have to start applying your domain expertise, some statistical techniques. You're going to have to visualize the data. And all of these things start to show you signal in the data that you can use to improve the predictive power of your models. It is fascinating, and you could spend an enormous amount of work there, and it will not be a waste of time. I think the thing where it gets really frustrating, and I almost look at this, I'm sure you guys have also seen the hype cycle from Gartner. This is a very useful metaphor because, when you first start, you get super excited. You're going up that slope, and you get up to the top, and you just think, man, I can do anything. And then you start building, feature after feature after feature, and you plug them into your model only to realize they're making your model worse. It can be very, very frustrating as well. But eventually you start getting to a point where you're like, okay, I'm really seeing these 4 or 5 features are starting to really create some separation in my data that I can see about visualization. And now I'm getting somewhere. And then you're heading back up that slope and you're like, oh, okay, yeah, this is getting better. But that whole steep decline from the peak of inflated expectations can be a very frustrating drop off when you start spending hours building features that end up only making your model worse.
Right, or you get to that point where you start climbing the mountain, and the mountain gets steeper, so you put 10 hours in, like, yay, I've improved my model by, say, 10%, and then you put another 50 hours in, and you only get 5% improvement.
You're absolutely right, and that is one of the unfortunate realities, too, is the exact percentage varies depending on what it is you're trying to do. It's actually relatively easy to get way over 50%, better than a coin toss, and it's actually not that much harder. You can just use decision trees and basic features in the data, maybe combine them in an interesting way, and you'll start getting into the 70% predictive range in a fairly generalized way pretty fast. But every micro percentage you get beyond that is going to be hard earned. It just takes experience, and you just got to put the time in. I mean, nothing's free above 80%.
Oh, I would say I think it's an interesting to have to explain that to kind of business decision makers, because you tell them, hey, I got 87% predictive accuracy here. Well, they'll say, well, why not 100%? Well, that's not quite how it works. Have you encountered that? Because I have a few times.
Yeah, of course. And I want to be clear for anyone who's hearing this podcast. I'm still in the learning phase of my career. I'm not an expert, but I aspire to be. I stayed at a Holiday Inn Express last night, so just keep that in mind. But I'm a BI guy who is aspiring to be a data scientist when I grow up. That being said, you're absolutely right. It does take some explanation and convincing, because I think a lot of non-technical managers feel that if they simply put more pressure on you, or just push a little harder, then you can go from 80 to 95 or 100%, and that's almost never the case. I mean, it takes an enormous investment to get very incremental improvements after a certain point, but you do have to have that conversation, and there are ways that you can just kind of show them. I think the simplest way to say it is someone's like, look, why is the accuracy of our forecast only at 85 or 86%? And I'm like, look, basically you're trying to model the inherent chaos and entropy in the universe. And if anybody could solve that problem at 98% accuracy, they would literally be at the top spot of the richest people in the world. So we need to set some expectations here that this is a hard problem.
And then the other problem is, if you really want to blow their minds, is you explain the dangers of overfitting.
Oh, yeah. Explaining that to a manager, I think that one is probably a little easier to explain, but ironically, it's one of the pitfalls that even experienced practitioners can fall into, which is why you have to be inherently suspicious as a data scientist of results that look too good to be true, because the last thing you want to do is put something out there and everybody gets excited, and then you start applying real-world data to it, and your accuracy goes from 98% to like 43% in about 10 minutes.
Right.
But yeah, overfitting is a constant threat and a constant risk. I mean, it's really easy to do. I know a lot of people use the Titanic data set on Kaggle. If you look at the all-time leaderboard, it's really funny because there are quite a few people who have results that show them at 100%. Well, you kind of wonder, how could I get 100%? Because, when I first tried that practice competition, it was really easy to get way above 50%. Because, if you say, look, male, female, well, you're going to be above 50% right away if you predict that females are more likely to survive the Titanic. It starts getting a lot harder to get into the 80s. I found out because, I spent several long evenings trying to improve my score, and it usually got worse. Well, but then you go, well, how could you get 100% on that? Well, there's at least two ways you can do it. You can be a really talented data scientist, in which case you're probably not spending all your time predicting something that happened that long ago. Or more likely somebody cheated, or they made a really rookie mistake like putting their target variable as one of their predictive columns. Well, of course it's going to be 100%, right? Because when you train your model, you know the result as a feature, and you'd be amazed at how often that happens. But the other way to cheat is, well, I already know the answer because we know who lived and died. If you simply create the target data set based on research on Wikipedia, well, you'll get 100%. Again, assuming there were 50 people who we didn't know their fates on the Titanic, that overfit model is likely to be extraordinarily wrong on those data points.
Darren, you mentioned a couple of minutes ago, you were talking about the conversations that you have to have with business people. And I want to return to that conversation because I know from experience, from hanging around you and working with you, that you have quite a gift for that. Your current role, you serve as a project manager. Is that correct?
Yeah. So, Microsoft has standard titles, and then we have more role-based titles. If you were to look in the HR gallery at Microsoft, then I'm listed as an engineering program manager. That simply means that I spend my life working with technology as opposed to business processes. But that's no excuse to not understand the business that you support, right? I think the most effective practitioners of technology understand the business. And that's actually a requirement in data science. You literally can't build features if you don't understand what problem you're trying to solve.
Sure.
So, supply chain is an interesting area to work in because it's different from a lot of other parts of Microsoft where we're just building the best software in the world. And that's a hard enough problem on its own. Trying to understand what customers' needs are, what can I do within a reasonable amount of time, how can I do it without breaking the product, all these kinds of things. But building software, it's a great thing that we do. But in a business group like supply chain, it's a little bit of a different challenge because you're dealing with many, many different interconnected processes, each of which impact the whole. It's really a system. Supply chain could easily be described as one giant optimization problem because you're always balancing constrained resources. I only have so much money I can spend before I don't make any money. I have to have a certain amount of inventory in the stores or people are going to be very unhappy when they go to buy a Surface at the,
right.
The Microsoft store in the Bellevue Mall. So, there's lots of things you have to optimize because, you can't just maximize everything because then you would be out of business. So you do have to balance those resources, and the best way to do that is with data. And, that's a journey. Obviously, Microsoft has a rich history of using data and building products to do that. But at the same time, like a lot of people, we're continually learning how to transform our business with data, not only to make decisions like we've always done with BI, but again, using that data to optimize our business, save money, make our customers happy, all those types of things. And it's a really complicated space because everything's connected to everything else.
Interesting. You place yourself in the same category I place myself as a BI practitioner who is slowly moving into data science. I'm right there with you. Frank's way ahead of me, by the way, and he may be way ahead of you too. I don't know, but Frank is working on he's working through the Microsoft Data Science certification. I know he's stoked because next week he's going to start the capstone project. But that's an interesting, and I think it's a path a lot of us are trotting, making that transition from what we described as business intelligence in the past, and even currently, into data science. I don't see it as a dramatic career shift because doing business intelligence, we applied statistics, we wrote reports, which performed some analytics, Talk to me about what you see as the differences between those two fields.
To me, one of the biggest mind shifts going from a descriptive analytics, which is really where most of BI has traditionally lived, I capture data that comes out of the business processes and whatever the business you're in.
Right.
And then I look at that to essentially measure business performance over time. And in that case, when you're dealing with data quality, you're dealing with things like, did the transaction system send me all the information that it was supposed to? Did I load it faithfully into the data warehouse? Did I do it in a timely fashion? And those things are all super important, and they're hard on their own. One of the things that I'll mention real quickly is that people often talk about the waves of BI or, the different phases of that, what stage are we in right now? And, they'll think, well, it should be all about artificial intelligence. All this other stuff is old school. It's not important anymore. Well, that's just silly, right? Because, if you predict the future and you don't learn from the lessons of the past, history has taught us that doesn't go well. Whether you're using your BI platform as one of your data sources, if you're a dimensional modeling practitioner like me, I've been a Kimball fan for as long as I heard of him, maybe 15 years ago. Those things are still super important because one of the things that you have to do as a data scientist is you have to get data kind of into a structure that lets you extract those features and build the features that you need. And a dimension is a great place for that because not all data science problems are big data. I could point you to a few examples. And as a matter of fact, most data in supply chain is not big data. And so I think there's an enormous amount of value that's still found in that BI platform. However, I think there is a difficult transition if you're coming from a place where you're only looking backwards into history. The things that you do to build either prescriptive solutions or predictive solutions with very typical machine learning techniques, those raw columns you get from your data sources is just a starting point. And, there's sort of some cognitive dissonance of, wait, I'm creating data. That's a bad thing. Or you're combining columns that have predictive power, but there would have been no reason to do that in a traditional data warehouse because in general, you're trying to separate things so they can be used for groupings. And there's a bit of a difference in how you structure your data and what data quality means because, frankly, one of the bigger problems in data science is not about do I have a faithful representation of the data in a timely fashion. It's more about can I stitch together an end-to-end picture of everything that's involved in the life cycle of the thing I'm trying to predict. And unfortunately, most companies' systems were not built with that type of end-to-end view. They were built over time. There's tons of technical debt in them. Data is overloaded all over the place in fields. And there's lots of challenges when you start pulling all this data into one place and you're trying to, quote, clean it up for machine modeling. It's a different exercise, and it does take a bit of a pivot to start thinking about the data that way.
As an outsider, as a software engineer, not too long ago, I would have always thought as kind of BI as part of the data science space. Yet the closer you kind of get to the data science space is that, well, it kind of is and it kind of isn't. And I think you did a great job explaining what are the points of confusion and pain points for when you're coming from a BI practitioner background into this space.
I am not a practicing member of the data science team, as I told them, for both selfish reasons and as an extension to my role in the BI space. I really want to spend as much time as possible with that team. Not surprisingly, Microsoft has an interesting org structure, and they keep changing their minds of whether the technology team should be embedded in the business group or if we should be centralized. Well, where we are right now is we have a group of business partners that essentially are driving the supply chain itself from a business perspective. And then I'm part of the technology team that supports the systems and the technologies that are used to drive the supply chain. Specifically, my role is as the solution architect for the analytics platform. And we, not surprisingly, again, BI is easier to get your hands around, and we've done that pretty well for a long time. And so we partnered very heavily in terms of how do we plan our backlogs, how do we prioritize things. But I'm very excited because I have an opportunity now to do the same thing in more of a pure PM capacity and partnering with our data science team to learn from them and to try to bring some of the same life cycle and program management, I should say, to that side. One of your past guests mentioned the team process for data science. And it's an interesting framework because one of the things that I've often seen in my experience is that, when you use things like TFS or Visual Studio Team Foundation Server, it's easy to bake your whole process into a software development framework like that. It's traditionally been a little bit more difficult to bring a software engineering paradigm to BI, database development. Microsoft has lots of tools to help with that, but it's still not quite as streamlined of a process it is with pure software engineering. And I'm finding that data science has similar challenges. Instead of managing the processes more or less from at a workstation level or in Azure machine learning, there's an opportunity to use a framework like TDSP to say, look, let's bring software engineering as a practice to data science as well. It's an interesting area, and it's a fairly new release for Microsoft, but I think it's a very useful thing because I've seen the benefits of it from a BI platform standpoint.
It is interesting to see kind of the same problems, crop up again and again, but just in different contexts. And it's kind of like, well, once you get to a certain point in the field, you make certain assumptions about certain problems being already solved, and then you kind of mash it up, creating a new field, and it's like, oh, well, we have to relearn these lessons again.
I had a recent experience a few years ago here at Microsoft where we were working with a company that we had acquired, and they had a lot of non-Microsoft technology, which caused me in my role to dive in and say, look, we figured out how to really manage the SDLC for data warehousing with Microsoft tech. What's the story on this tech? Because at that point we hadn't decided we were going to migrate them off of this third-party technology and into a Microsoft stack. And it was amazing to dig into it across the industry for even pretty common technology to see that people just didn't have that engineering mindset. There was a lot of manual activity, a surprising lack of source control around code, and just all the standard things that you do. And so, that's exactly what I mean. It's just, we figured it out for BI now for the most part, and now we're doing the same thing in data science.
As a longtime BI practitioner, what would be the advice you would give to someone who's also a BI practitioner and they see kind of the writing on the wall about data science becoming more and more important in their field? What advice would you give to them in terms of how to get started and what pitfalls to avoid?
That's actually an easy one because I was saying, I've gone through this myself recently. So I think like any new technology problem, you just have to get started. I know for years now, I was like, look, if I only could go back and get a master's degree in this, or if I could only complete, this whole series of classes online, or if I could read this book, and, you gather all this information that is useful, there's no doubt, but all of it is teaching you about the theory of something. And in my experience, theory has never built anything. An engineer sitting down and writing code is what builds something. And so the best advice I could give is, look, take a problem you're familiar with and just re-envision it as a data science machine learning problem. You don't need many tools. I'm a big fan of R. If you did nothing but looked at ggplot2 for visualization, some of the tidy packages for doing some of your data cleanup, and used, a decision tree, you would be amazed in a weekend what you could accomplish. So just get started. It's literally that simple.
Awesome.
Yeah, I absolutely love that advice. And I had to put my mic on mute too because I was applauding here. Fantastic advice.
For folks that are kind of curious and they're standing on the outside, would you recommend they look at R first or maybe some of the Python packages around this space?
Well, Frank, considering we just met today, I should probably ask, are you intending to start a religious war with that question? Or
as I said it, I'm kind of like, I want to phrase it in a way that's not going to start a religious war. Because the whole Java versus .NET, the VB versus C#, like that never solved anything. But no. I think my personal experience is that I was at a juncture when I had to, I'm learning kind of my background is C# and Java and kind of, software engineering. At some point you have to pick at least which one are you going to learn first. That's probably the better way to phrase it.
Yeah.
Right.
So
which one to learn first? Because realistically, if you're going to do anything meaningful, you're going to have to know R and Python.
Yeah, and SQL.
And SQL. Well, I'm assuming you already know SQL.
Yeah.
If you're, right. But that is an assumption I made. So kudos for catching me on that. Where would be a good place just to start? Now, I'm not saying if you pick one, we're not dissing the other. So before the flame wars start. For me, I chose Python simply because it's more like C#. It's more like, kind of the structure of what I'm used to. Whereas R takes a more of a functional type approach.
Yeah.
That's why I made the decision I made. And, I'm learning both. But, when I started, I chose Python. So, you mentioned R, so I'm assuming you chose R. And
yeah, well, I think the first thing I would say is you should never artificially limit yourself to one technology or the other, because as you get into one problem versus another problem that you need to solve in your job, you're going to find that different tools have different strengths and weaknesses, like everything we use, and one or the other might be a better fit. I mean, it may come down to, I need this library specifically, and I can't afford to wrap it in R, so I need to do it natively in Python. But that being said, use the right tool for the right job, but at the same time, I think the general advice I would share is, if you're coming from a pure software engineering standpoint, you're probably going to be more familiar with Python, because like you were describing, it feels like a regular programming language, if you're in C# or Java or something. The reason I personally like R, and that's where I started, is because I come from more of a pure data background with SQL. And while it's completely different than SQL from a syntax standpoint, it's designed to help you work with data from the ground up. I mean, it was created by statisticians for using data. And, one of my friends calls it the world's greatest calculator, and it absolutely is. I mean, there's literally thousands of packages, but I mean, if you just started with some of the ones I mentioned earlier, there's infinite amount of resources online for either language, for R or for Python, to get started. And so I think, that's my natural inclination, is if you're a software engineer, maybe you'd be more comfortable starting with Python. If you're a data person, I'd probably start with R, because you'll be absolutely amazed at what you can do with just a few lines of code. It is truly astounding.
That's a good answer. And hopefully we didn't start any riots anywhere.
No. They're both awesome. I dealt with this for years, obviously, with the whole Kimball Inman thing, right? And at some level, it's just stupid, because, again, there's a time and a place for everything. And, I think the religious wars never solved any real world problems that a business needs to solve. So,
or in the larger picture, it usually creates more problems.
Yeah.
Yeah, I absolutely love that approach, Darren, where you're talking about kind of putting tools in the toolbox, right?
Absolutely.
And so, yeah, you're ready to solve a problem that looks like R will solve it. You're ready to solve a problem that looks like Python will solve it. And if you only have one tool in your toolbox, you're carrying a hammer and everything looks like a nail.
Yeah,
so,
yeah. You should always be learning, and adding new tools is only going to make you better. So
absolutely. Completely
just start
agree.
somewhere.
Absolutely. Love that.
And this is the point in the show where we thank our sponsors who make Data Driven possible. On Data Driven, we talk a lot about data science, machine learning, and artificial intelligence. But did you know the hardest part of any data science related project is data integration? Data scientists often call data integration data wrangling, or the icky word munging. But it's all about making sure the analytics engine that you're using has valid and clean data. Enterprise Data and Analytics specializes in data integration and can help your enterprise build better data integration solutions faster with best practices and automation. Enterprise Data and Analytics offers training and consulting services for SQL Server Integration Services, SSIS, and Business Intelligence Markup Language, or BIML. Visit entdna.com to learn more. Enterprise Data and Analytics. Data, it's in their DNA.
We're at the part in the show where we ask questions of our guests. It's a set of a handful of questions that we like to go through. The first one we like to start with is, did you find data, or did data find you?
Well, that can I pick a third answer?
Sure.
So I would say, and I'd be surprised if anyone is ever giving this answer, but I would have to say that I married into data.
You are the first person to marry into data that I'm aware of.
Yeah, so that probably warrants a little explanation.
It does.
So my brother-in-law has long been a Microsoft consultant, software engineer, and database architect. He had all the certifications back when they actually really meant something. I really got a lot of great experiences and opportunities with him, because he, as an MCT, he was training classes in SQL Server, Visual Basic, And, and if it was a new class, he was like, hey, can I come over this weekend and just give you this class for free to practice? And I'm like, yeah. So, but data was always really his main passion. And he really set a high bar for me. And he taught me a lot. And so that's why I jokingly say that I married into it. And I have a picture I can send you, Andy. You know what they do at PASS, where they have that giant wall that everybody writes on about how they got into their first job and that sort of thing. And there's some really creative answers on there. And one of the ones I wrote a couple of years ago was related to my answer to this question, which is I was a classical musician by professional training. And I think an early question by both my brother-in-law and my father-in-law was, so explain to me exactly how you're going to support our daughter. So, yeah, the data was a great way to do that.
So what's your favorite part of your current gig?
The best part of the current gig is it's like being a Microsoft MVP, except you're just an employee, because, one of the greatest benefits of being an MVP is having more direct access to the product teams. Well, if they're coworkers, you get that baked into the job. Between that, all of the internal resources we have, having access to all of our software, both on-prem and in Azure, things like the Data Science Summit. I literally have been trying to figure out a way to get 36 hours into the day because there's just not enough time to do and learn it all. Just having access to all those things has to be the best part of the job.
Yeah, I have to say and plus you're on campus too, so you gotta, if folks who are listening have never seen the Microsoft campus, you should make a trip at least once. It's like Disneyland for geeks.
Well, and I probably should mention too, there's an awful lot of smart people. You've had a couple of them on recently. Rema, right? She's been killing the keynote at PASS for a long time. And there's lots of people at Microsoft that you're just like, man, I get to work with these people every day. That includes my team too in supply chain. There's some amazing people that I get to work with. So I've had the good fortune over my career to work with a lot of people. But I think the cool thing about being at a company like Microsoft is there's a lot greater concentration of people like that all in one place. It's kind of like when I played Little League Baseball. It's like being on the all-star team. There's so many people that are just right there, and it just makes it even that much better.
We have a complete this sentence. When I'm not working, I enjoy blank.
Ooh, I forecasted that one earlier. So I would have to say classical music, and it's so beautiful in the Pacific Northwest. I didn't tell the hiring manager this, but I might have worked for a lot less, but it's so beautiful here. I love the outdoors. So I would definitely say classical music and the great outdoors, hiking, skiing, all that stuff. I just love it.
Especially in summertime in the Pacific Northwest is just stunning.
When I got recruited to join Microsoft, I was meeting with somebody in Dallas because I was there of all things for SAP training. And it was like 100 plus degrees. It was humid, like like you guys, if you've been to the South, you know what I mean by humidity. And it was rough. And so a few months later, actually not even that, maybe a few weeks later, I came out to Redmond. It was in July, and it was like 78 degrees, no humidity, driving up 520, and you've got Mount Rainier sitting right in the middle of the road, right? How can you not be inspired to write good code when you see that kind of stuff all the time?
So here's another fill in the blank. I think the coolest thing in technology today is...
As a Microsoft employee, I'm probably obligated to say Azure, and it's actually true. In all seriousness, I think the cloud has to be what I would mention. I'm fascinated by things like self-driving cars, and I could talk about that from an interesting technology and even an ethical standpoint, which, data science has lots of interesting edge cases about the ethical dilemmas you might find yourself in with using data for certain things. I would have to say the cloud, it has to be it. And I say that somewhat begrudgingly because I've been in that camp as a BI practitioner of, look, man, we've got awesome things like fast-track data warehousing. I can use SSDs. I can build the most killer infrastructure and do things ungodly fast. It's just truly amazing what you can do. And so for a long time, I'm not going to say I was a detractor of the cloud, but I was definitely being sort of drugged with my heels dug in a little bit. There were some interesting things about the cloud that I don't think I fully appreciated before I dove in with both feet, which is, in the cloud, when you need a new SQL Server instance, you can just write a few lines of code and boom, you got a new instance. There's no building out infrastructure and optimizing network cards and HBAs and so being able to focus purely on the innovative aspect of what you do and not have to worry about, am I going to run out of disk space this weekend? That is a real game changer. Couple that with all the things that you can do in the cloud now. It's truly astounding. So I would definitely have to say the cloud wins for me.
That's a good answer. Yeah, I agree. Because I was not a believer in the cloud early on.
Yeah, and to be clear, there are still times when it's incredibly painful. I mean, when you're trying to do something really innovative, you can realize that you're maybe a little more bleeding edge than you realized you even were. And so you have to be careful. The cloud is still maturing. I don't care whose cloud you're talking about. It's there are hidden dangers and things that maybe you shouldn't do yet. Microsoft's really big on the growth mindset and not letting your concerns about something keeping you from moving forward with it. And obviously with a healthy dose of risk management, but at the same time, I've become a believer in the cloud.
Very cool. Well, Frank, you just did your melee, right, between AWS and Azure Machine Learning.
I did.
And so who won?
And you're going to hear it here without paying the pay-per-view price for the boxing match. Basically, Azure won. I would caution the Azure side of the fight to maybe take 1 or 2 days off from the gym, enjoy the victory. Because, I used to work at barnesandnoble.com before it was barnesandnoble.com.
Ooh.
So I have learned the hard way not to underestimate Jeff Bezos.
It's cool to see the innovation happening on both sides of that fence. Microsoft has always done this thing that I feel is they get very little credit for from both technologists and the stock market, and it's integration. And I know that sounds like a dumb little thing, but if you know how to do one thing in Microsoft technology, you usually know how to do something like 8. The dumbest example I can think of is copying and pasting in, Office, which I learned how to do as a digital immigrant. I'll throw back to the Mark Tabadio show. Probably back in the 90s when I started using Office. I learned how to copy and paste in Word, and I could do it in Excel. I could do it in Access and the other technologies in Office. And I'm seeing that same sort of thing happening in Azure.
Yeah, well, and to the point you just made, let's all have a moment of silence for Clippy. We loved Clippy.
Clippy lives on in our hearts.
A couple of months back, I actually took the time to go take a tour of the Microsoft archives. And if you're ever on campus, I could not recommend that enough. It's like walking through your entire career, like in an hour. And that's actually where they keep the Clippy foam costume that people can rent for events. I think they had that at one of the recent conferences. And so, yeah, they pulled that thing out.
Yeah, there was a picture was on Twitter of Mary Jo Foley, like it looked like she was boxing.
Oh, that's right. I saw that.
Yeah.
That was awesome. But yeah, in terms of things being baked into all the products, that's another reason that I like R, because I don't even have the count right offhand, but I mean, there's probably at least 10 products that we make that give you the ability to integrate R in some way in a data product. And so it's pretty awesome. Like whether it's Power BI or, Azure Machine Learning, I mean, it's just all over the place.
Complete this sentence. I look forward to the day when I can use technology to blank.
I look forward to the day when I can use technology to. Okay, so again, I'm not intending to start a religious war over fans between Star Trek and Star Wars. But I would, as a huge Star Trek fan, I would have to say I need a human teleportation device now. I do a lot of reading in the world of experimental physics, and we're making amazing progress in teleportation, but unfortunately it's still at a molecular level, and I think they end up losing it about half the time. But given that I'm up here in the far corner of the U.S. and most of my family's in the Southeast, I would absolutely love a teleportation device to help me avoid the airport. And but frankly, given that that's probably a long way off, I would say I would settle for just being able to have a reasonable conversation with my computer, because I hate typing. Cortana gets me a long way, but yeah, it's still a hard problem to solve. So I think we're we got a ways to go yet before it's where I want it to be. But that would be my backup, is I want to just talk to my computer.
And our final question: share something different about yourself, but do remember it is a family podcast, and we want to keep our clean ranking on iTunes.
Sounds good. Yeah, I have 2 young daughters, so I'm well versed in keeping it family friendly. So I would say I sort of let the cat out of the bag on this one earlier too, but I would have to say that something that, most of my friends know about me is that, I don't have master's degrees in computer science. I happen to have 3 degrees in classical music. 2 of them are in piano performance, and 1 of them is in musicology, which is basically music history. And I taught at a college level for a few years, and I loved that. The study of music and the practice of music changes your brain chemistry in ways that are hard to predict. I think there's been a lot of research into this and around neuroplasticity and all kinds of interesting things. Music just turns something on in your brain that it may not be the only way to turn it on, but it's an awfully good way to turn it on. And I think it helps you to approach problems in a different way. And so, but that being said, I had a family to support, and I was kind of at that transition where I was like, all right, I have master's degrees and I can teach, but I'm going to starve to death, because if you don't have a PhD in academia, you will be hungry a lot. and so I was trying to decide, do I want to invest 4 years of my life into getting to that point, which would have been awesome, or do I want to just look at one of these job offers that are on the table now to get into technology? And I was fortunate that I loved both, so it didn't really feel like a hard choice. So I went the technology route. But that being said, even my master's thesis in musicology technically was a data science project, because I was essentially the field really didn't exist then. Today it's called computational musicology, but essentially what it is it's applying statistical, machine learning, artificial intelligence techniques to the analysis of music. Essentially what I did for my master's thesis was I took about 50 recordings of a piano work by Beethoven, and I didn't have a good way to do this in an automated fashion, so I spent 3 months capturing my data. You remember that part in data science about you spend 80% of your time getting the data? Well, it was true then too. So I had to capture all this tempo data in a manual way. But once I had it, I had this incredibly rich data set that I could use to apply statistical techniques for looking at trends in performance practices. Because again, if anyone who studied music, there are certain things they say. If you're playing music from the classical period, you don't change the tempo more than just a little bit. You have to keep a steady tempo. All the kids that have had piano lessons hate metronomes, but that's why. I was one of those people that like to say, oh, yeah, right, because you're telling me to do that, but when I listen to 50 recordings of professionals, they don't seem to respect that. And so I was able to go, you know what? Okay, maybe this group of pianists from this country in this decade, maybe they did it a little more, but, the Italians in the 70s were much more free with the tempo. So, again, I was just applying statistical techniques, regression and lots of things against this data set I'd captured to understand performance trends over a large group of performance data. And I kind of never looked back. I got hooked on data back then.
Interesting. Have you seen some of the work that's gone into having AI generate music?
I have. It's interesting. I've seen some of the work that Google has done in terms of generating visual art, and it's pretty astounding how good it is.
Interesting. We'll have to have you back on the show. We can talk just about that aspect of AI and data science.
Yeah, no, that would be interesting for sure. I know I sent Andy an article a while back where we were talking about one of the problems with generating drums electronically, with a drum machine or a computer or however you're doing it, is not making it feel so sterile and capturing, how does a human drummer sound versus a computer-generated, rhythm section. And it's pretty astounding. There's some research that's gone to it that basically said that there is a fractal pattern and, all the other things we see in nature about Fibonacci sequences and the golden mean, and these variations happen in a very interesting way. In technology, the companies that make the technology to essentially generate rhythm and music, they're figuring this out by these data science techniques, and then they can build that back into the algorithm and make it sound like a real drummer, which is, in a lot of cases isn't going to be good for career longevity like a lot of people, which is, again, one of the reasons I'm getting into data science. Until we figure out how to automate feature generation 100%, I feel good that's going to get me pretty far along until I'm ready to retire. So.
Well, on that note, I think this has been a great episode, and we really enjoyed having you on the show, and we'd love to have you back once again to talk about kind of data science and the arts. You've been listening to Data Driven. Be sure to head over to datadriven.tv for show notes, as well as sign up on our mailing list. And Andy, don't we have a special name for folks who are on our mailing list?
We do. We call them data drivers. Frank, this was a fantastic show. Thank you, Darren, for coming on.
It was my pleasure. Thanks for having me.
Thanks for listening to Data Driven. Don't just listen. Become a data driver by going to datadriven.tv to sign up to join the community, access to special events, tips and tricks, and more. Sign up today at datadriven.tv.